Na świecie, głównie w Polsce, ale również w Niemczech i w Argentynie. Robimy bardzo różne rzeczy. Może tak się gdzieś przełączę. Znaczy, w nomenklaturze oficjalnej jesteśmy software house'em. Oczywiście moglibyśmy się przedstawiać inaczej, ale to w sumie tak się do tego samego sprowadza. Mamy sporą grupę programistów i .NET, Java, frontendowców. Robimy dużo na AWS i na Azurze. Tak trochę nawiązując do tego, co Michał przed chwilą opowiadał, można do nas wejść do biura również poprzez rozpoznawanie twarzy. Mamy Cognitive Services zaprzęgnięte, opisane przez naszych programistów. Nazywa się to Ewa i ona zazwyczaj rozpoznaje ludzi, ale nie zawsze. Jak prezes przyjeżdża, to go rozpoznaje, a tak z pozostałymi różnie chyba. Także szukamy różnych osób. Akurat jeśli chodzi o .NET, to taki mamy teraz sezon martwy, to jeśli chodzi o koniec roku, natomiast zachęcam, żeby gdzieś tam do nas zajrzeć, bo zdarzają się już tak na początku roku, że jakieś tam projekty się pojawiają i wtedy możemy kogoś też z takiej specjalizacji szukać. I na pewno chciałbym zaprosić też na nasze wydarzenie InCloud, które się widzę nieszczęśliwie pokrywa terminowo z następnym etapem podmiotowym, natomiast będzie u nas w biurze. Biuro mamy tuż obok Kapitolu, także w centrum miasta. Tam jest Retro House na 3. piętrze. Także jeśli ktoś miałby chęć posłuchać trochę o tym, co robimy, czy jak możemy podejść do robienia rzeczy na AWS-ie czy na Azurze, to zapraszamy.
A to o czym będzie ten event?
Do końca to się nie powiem, jakie będą wystąpienia, natomiast to one nie są specyficzne technicznie, tak jeśli mówimy na przykład, że będzie tylko Azure albo tylko AWS. Zresztą mam tutaj na sali też osoby od nas z firmy, bo akurat chłopaki Rustam i tam jest też Paweł, pracują w jednym projekcie .NET-owym, który stoi na AWS-ie, więc da się to jak najbardziej łączyć.
Prezentacja będzie IoT, infrastruktura jako kontekst.
Okej.
To ja ode mnie tyle. Ja przekazuję głos Rustamowi. Mamy też dla Was upominki dla jakichś aktywnych uczestników. Rustam, ja zachęcam Was, żebyście zadawali mu pytania i ja pewnie osobę, która będzie najbardziej aktywna, jakoś wyróżni. I tam jeszcze na stoliku są jakby co nasze firmowe bączki, notesiki i takie, nazwijmy to, komino bandamki. Więc jakby ktoś chciał się poczęstować, to też zapraszam. Mam ich więcej, jakby trzeba było.
Komino panda.
Okay, I will speak English, by the way. I hope you're ready. So, hi everyone, it's nice to be here tonight, and tonight we'll speak about better transient error handling with a poly library. So, we will start with a definition of transient errors, what they are, why we need to handle them. Then we'll speak about policy in poly and variety of policies, syntax that we should use and why we should use them. Then we'll speak about policies, thread safety and state of policies, because it's quite crucial to understand these topics to use policies properly. Then we'll speak about policy registry and integration of poly library with the .NET Core. But first of all, let me introduce myself. So my name is Rustam Ashurov. I'm working as a senior software engineer at Intu, and here is 20 the most exciting technologies that I really like and want to be proficient with. So if you have some questions, maybe topics and ideas to speak about, please let me know after the speech, and maybe next time when I will be here, I will speak basically about some technologies that you are interested in as well. Okay, and let's switch back to the main topic. And let's answer what are transient errors and why we need to handle them. Well, basically, transient errors are any errors in our code that have temporary nature. So they can happen and at the same time they can disappear on the next call maybe. And you can say like we always had such errors, why we need to handle them now? And the answer will be that in fact current architectural approach, ideas, some technologies and frameworks like microservices, serverless, clusterized solutions, cloud-based applications, maybe distributed databases, domain-driven design, all these ideas forces us to make our systems more granular and distributed. And unfortunately, all these microservices in your systems should be able to communicate with each other, to provide some services to each other, or to maintain consistency of state. Yeah. And unfortunately, usually they're using for this communication some network connection, and it's usually global network, so internet. And the internet is not a reliable provider of communication. Such connection could fail any moment, and it's very temporary error because the connection could be established any moment soon. At the same time, even if your request was successfully delivered to some database, in-cloud application, third-party service, or maybe another part of your own context, so another microservice, there is no guarantee that this request will be processed at all, processed in required time, and you will not have some timeout exception. Or even if it will be processed in time, there is no guarantee that the response that you will get will be successful result. So maybe there will be some error response. It's totally fine. For example, if you are using HTTP client, it's totally fine to have some non-successful result with some bad HTTP code, and you need to handle this result somehow. And in fact, such errors also could be transient, because, for example, your request will be not processed because there is no enough resources at the moment, but at the same time, on the next call, maybe there will be no so high load on the service from the clients, and your request will be processed successfully. Or maybe the service will self-heal somehow. For example, like horizontal scaling, or maybe it will be just restarted. So it's as well temporary errors, so transient errors. Even if you are not working with network at all, so using, for example, a local database or local file system, it still could provide some temporary errors because, for example, another transaction can log some data in the database, and another process can basically capture the control of some file. Still, it could be potentially a temporary error, because on the next call, maybe these logs will be exposed by other transaction, and file will be available. So we need to handle such errors in a very specific way. Or maybe we shouldn't. Well, for sure we can just rethrow exception or return bad result to the client code, like we always do. But it's not the best approach, because we're basically just shifting responsibility of handling such error to our client code, and it's not the best way how we should do it and how our code should do it. Because client will probably handle it. If not, maybe application will be terminated. It depends. But another really big problem, that at some moment your client will definitely decide to retry naturally the execution of this request. Because, for example, if I'm using some mobile application, like banking application, I need to know how much money I have on my account. If there will be one error during the request, I will be not stopped. So probably I will try again and again and again, because I need to know how much money I have for this moment. And for application, it's a problem, because every time you will have to handle this and process this request from the beginning, again and again and again, in the best way. Maybe on the second call, in the moment when it failed first time, it will be processed. But let's imagine that it will not. Maybe it will be processed only on third try. And what if you have not only one client, but hundreds, thousands? You have a high throughput application, and every time you will process requests again and again from the beginning. It will take additional resources. It will consume a lot of computing time, and probably will affect on invoices in the end of the month. It would be much easier and better to retry this potentially problematic place if you can understand that it's a transient, temporary error. How we can handle that? We can for sure make our own solution, create our, I don't know, service, a library, but it's not probably what we want to do because we need to make it, we need to support it, we need to bug fix it, we need to create documentation for users, we need to distribute it, and so on, so on, so on. Even if it's very funny for us, who will pay for it? Probably not our clients. Our clients probably want different kind of applications and solutions. Fortunately, we're living in open source era, and there is one open source project that we can use freely. It's a poly library. Poly library is a library that very mature in .NET. It provides a lot of functionality for transient error handling and adding a lot of resilient strategies to our code. I'm just curious, how much people here are using poly in their daily programming? 1, 2, okay, not a lot. Okay, so probably it would be useful to speak about poly. Poly is distributed as a naked package, so it's very easy to consume this library, and it's available to use in .NET Standard, .NET Framework, .NET Core, Monex, Xamarin, like everywhere in .NET infrastructure. We basically are working in the in Tandem team. We're working with the Tandem London Bank, and we're using Poly almost everywhere where it's possible to handle transient errors. And we're kind of happy with this library. It helps us. So when I said about maturity of this Poly library, I was not lying, because from the 2013 till the 2018, you can see the chart of downloads, and it's quite like similar to Exponenta. So a lot of downloads for 2017 to 2018, probably because of usage of all these technologies that I talked about. The main functional chunk, the main functional unit in Poly is policies. Policies are just the classes that could be instantiated and be used. They are nothing more than strategies that should be applied against some functionality of yours. You need to create some business logic or application logic and use these policies as strategies to apply against this functionality. How it looks like in real life. In real life, you need to create a policy instance. You can start with a policy class, and we apply in syntax, create an instance of Poly. And almost always you need to configure what this Poly should handle, which transient errors. There are two ways. First is to use some type of exception, and it's very natural for .NET because we use exceptions as markers of exceptional situations. But also you can describe some result value of your functionality, so when you will execute something through the policy, some results could mean transient errors. Yeah, for example, here I'm creating a policy that will be used with HTTP client. Sometimes this client could throw HTTP request exception. It will mean naturally a transient error for me, and policy should react. But as well, sometimes it could return totally normal response without any exception, but if status code of this response is bad gateway, I want to use policy as well. And then in the very end of this chain, I need to specify which policy instance I want to use, which policy class. Here I'm using retry class. So retry instance of a retry policy will be created. And the second step is usage of this policy. You need to provide somehow this instance to your code to execute this policy, so execute this strategy against some functionality. And this functionality basically will be a delegate that you will provide as an argument of execute method. Poly will on its own execute this delegate and apply strategy, some resilient strategy that will represent this policy against execution of this delegate. The delegate could be action without result or a function with a result. If it will be a function, the result will be captured automatically by policy and will be returned to your code. All policies in Polis have their asynchronous versions. It's very similar with a slight difference that you need to provide asynchronous delegate, function, or asynchronous action, and probably it will be the most used way, like instances of poly that you will use, because usually all communication over the network, this file system and so on, is usually asynchronous. All policies in Poly could be divided into families. One family is reactive policies. Reactive policies, as name suggests, react on something. And in fact, they are reacting on transient errors directly. So when something fails, they do something as a reaction. The first example is a retry. A retry will retry the execution of the delegate if it will detect some transient error. And it looks like this from the syntax perspective. You need to create an instance of policy, like previously, mark some exceptions or error results as transient errors, and then just execute policy against some delegate. If the delegate will throw the exception or exceptions that you specified or its children, or maybe will return some results that you also could specify as an error response, then retry policy will just retry the execution of delegate silently, and if it still will fail, and like on all retries, it will return at some moment, it will rethrow original exception or return bad result, unfortunately. And it's very natural in the way that Poly will try basically to work against some transient errors, but if nothing helped, it will just return original transient error to your code, and you need to handle it somehow. You can use default parameterless version of retry method, and in this case, this policy will retry the execution of delegate only once. So in the end, there will be two executions in the worst case. So the initial one, which is not retry at all, and one retry. Or you can use overload of retry method with some integer number that will specify the maximum amount of retries, so up to 4. The retry forever, it's a version of retry that will not let you configure the amount of retries, so it will retry again, till the successful output. And wait and retry and wait and retry forever lets you specify the timeout between each retry. You can configure this by giving as additional parameter a function that should return time span. What is important to understand that this function will be executed before each retry, so the value that it will return could be quite dynamic. Also, as an argument, you will have a retry attempt number that will basically specify the number of the current number of retry. So, based on this value, and with usage, for example, of math power function, you can create exponential backup functions. So functions that will return bigger and bigger time span on each retry, and it's quite useful because when policy is able to understand that downstream component cannot process the request, there is no reason to spam it again and again. It's better to make some break and let downstream component maybe self-heal, maybe scale itself or just reboot. The circuit breaker is another policy type, and if retry was optimistic guy, someone who like, okay, so probably this error is transient, so let's just retry again, and he would like retry again and again until the maximum amount, and some moment he will tell, no, probably it's not transient, let's not waste our time, let's just throw original exception. The circuit breaker is a realistic guy. He can understand that, okay, this downstream component just struggles and cannot process our request. So let's immediately break the circuit and will not execute anything. And it works in the way that it has some measurement. It basically calculates the amount of transient errors, so thrown exceptions or bad result returned, and when the threshold that you can configure will be exceeded, it will break the circuit, like this basically switch. And any delegate that we will place on execution of instance of this policy will be not executed at all, and circuit breaker will just throw the circuit breaker, I believe, rejected exception. And you can configure it in this way. Again, you need to start with a policy class, then mark some exceptions or results as transient errors, and then by default you just need to provide amount of consecutive exceptions, transient errors that should happen within instance of this circuit breaker to basically break the circuit for amount of duration of break. For example, here 1 minute. So in this example, if I will execute some delegates through the same instance of circuit breaker policy, yeah, it could be like they could be executed concurrently. But when circuit breaker will detect that there was 3 consecutive transient errors, it will totally stop to execute delegates for 1 minute, and any delegates that you will place onto it within this 1 minute time will be not executed, and circuit breaker will immediately throw its specific exception. This mechanism is very important to be able to not basically let your client wait for something that probably will not be processed, to not consume resources for something that will be not processed again, and to not spam downstream components. So if component struggles, no reason to basically just add additional requests to it. Fallback, it's kind of easy policy. The fallback policy provides you ability to configure some graceful reactions on transient errors. So if delegate that will be executed through this instance of this policy will fail, the fallback can execute some default action or return default value for your code. So in case if your code supports such way, for example, your business logic can afford default value to be returned to the client code, this fallback policy can help you a lot to not fail. And if you have a question, for example, if we will create this fallback policy and will configure to return this SOMRESULT type instance, and I will execute some functions that will return integer, how it will behave. In fact, poly is very type safe, so when you will create such policy, this policy will be of generic policy type, it will be strongly typed, and you will not be even able to execute any function that will not return this SOMRESULT type as a return value. So it's very hard to make mistake. Proactive policies is another part of poly policies, and if reactive policies were designed to react on some transient error and basically to handle them, proactive policies totally agnostic to your transient errors. They just add additional resilient strategies to your code, and to say the truth, they're very different, so let's just go through them one by one. The timeout. The timeout policy is able to start the execution of the delegate that you will provide to it, and from the moment when this delegate will be started, it will basically measure the time of execution. If the threshold will be exceeded, the execution of the delegate will be immediately aborted, so cancel it, and the exception related to the timeout will be thrown in your code. You can create an instance of timeout policy very easily. As I said, it's a proactive policy, so it's totally agnostic to the transient errors itself, so you don't need to configure any markers of transient errors. You just need to say how big timeout should be. You can configure it by amount of seconds, time span, or function that will dynamically return time span value. After basically this timeout, after the beginning of execution of delegate, timeout rejected exception will be automatically thrown in your code. The good question is how the hell it works. How Poly can cancel execution of my delegate? What's in black magic? And the answer is kind of complicated because there are two options for you. Which strategy of cancellation to use? Pessimistic one or optimistic? The optimistic is a preferred way for asynchronous operations, and I believe asynchronous operations will be a default way how you will work with the network, with the file system, some third-party APIs, RESTful APIs, and that's why we'll speak about optimistic way. If you want to use optimistic cancellation, your delegate that you will execute at some moment through this policy should support cooperative cancellation pattern. So it should be able to get the cancellation token instance as one of its arguments and be respectful to this cancellation token. So check cancelled state, and if, for example, cancellation token was cancelled, to throw exception or silently stop the execution of it in some loop, or at least to provide this cancellation token to the downstream components, for example, HTTP client or entity framework, something that will be able to handle the cancellation of cancellation token. And also you need to provide the cancellation token instance itself on the moment of executing of the policy. By default, you can give some default value of cancellation token. So like cancellation token none from system threading, or default of cancellation token, like most modern syntax. In this case, Poly will create instance of cancellation token on its own and will give on the moment of execution of your delegate another instance, its own instance, instead of this uncancelable default value. But you can give your own instance of cancellation token. For example, here I'm using cancellation token source, but in your code, maybe your client will be able to provide cancellation token. And in this case, Poly will combine cancellation tokens together, your one and its own one, and it will be possible to cancel the execution of delegate on the timeout or from your client code. So, for example, if your client don't want to wait 60 seconds, it can just cancel it, and the execution of delegate will be cancelled as well. Timeout is a very useful policy because it's kind of nice to be able to cancel execution of something that potentially will be never executed. If the generally execution of some like call to the third-party service, for example, takes like milliseconds, there is no usually reason to wait 1 minute. So you can just control this to expose resources faster and to provide maybe better result or default maybe result to your client faster. The bulkhead isolation. What is a bulkhead in real life? Probably it will be the best approach. The bulkhead in real life is a wall inside the boat that will isolate different parts of boat. So if you have a hole in the boat and water goes inside, another parts of boat will be isolated and full of air, so the failing part of boat will not let the whole boat to sink in the water. In the same way, bulkhead isolation policy works. It's still a policy, and it provides you ability to isolate some parts of your application from other parts. And if these parts will fail again and again, it will not let these parts to consume all resources of your application, or maybe machine or whatever, to not let other parts fail as well because of not enough resources, unfortunately. Again, like with timeout, how it works. And it works in the way that it provides you the ability to shrink the throughput of some parts of your application. It's easy to understand how it works if you are familiar with a semaphore sling construction. So, to say the truth, for someone who is familiar, under the hood, it exactly uses the semaphore sleep. So by default, all that you need is to provide integer value that will configure max parallelization. So amount of delegates that could be placed to be executed through this bulk policy instance concurrently. Yeah. So if I have an instance of this policy, I will schedule the execution of 4 delegates at the same time. They will be executed in parallel. But if I will place the 5th one, it will be not executed at all. And bulk isolation rejected policy exception or something like this, very specific to the bulk policy exception, will be thrown to my code. Also, there is additional functionality in the bulk policy. You can configure by another integer value additional queue size. So if there will be no place to execute delegate on the moment of execution in the main queue, the policy will take the instance of delegate, fortunately it's just instances of classes, and will put this delegate to additional queue to wait the free slot of execution on the main one. For sure, when there will be some slot to execute, it will take it in the first in, first out manner and execute. If on the moment of placing the delegate,
I was just about to ask whether those numbers in the comments, are they by mistake or are they supposed to be like that?
You're right, it's a mistake.
But both of them, like it says 7, 4, and then it says 2 actions. So I assume both of these are.
Yeah. I changed it just to make it like similar in the very last moment, and I forget. Sorry.
Okay, it's okay.
Yeah. So yeah, and yeah, because I just wanted to make it like similar.
Sure.
Okay, so in fact, if there will be no place not in the main queue, not in the additional queue, on the moment when you will schedule the execution of delegate, it will still throw the exception. If you're still not really sure why we need this policy, because it's quite complicated, you can imagine the work of this policy like a work of nightclub bouncer. So the guy who is standing in front of the club, and he has like 2 responsibilities. One is to check how much people inside the club currently, and if there are too many people, he will not let new visitors to go inside, because too much visitors, too hard to sort all of them. But at the same time, he should maintain this queue to be able to let someone in if he detects that there are just not a lot of people still for the club. So you don't want to have a nightclub half empty. And basically, bulk isolation works in the same way. And to say the truth, it's very easy to consume a lot of resources in one place. If you, for example, use a retry policy, and you configure something like 10 retries, and you have high throughput system, and you have like 10 retries per request maximum. And some downstream components just fail, not temporary, but totally fail. And you have like thousands of requests, and all of them multiplied by 10. Bulk will not let you kill the app. The cache. Probably all know what is cache, but what is cache policy? The cache policy is a policy that works in the way that when you schedule the execution of delegate through this policy, after the execution of delegate, if the execution was successful, it will store the result in the cache. On the moment of the next execution, it will be able to not execute delegate at all and take the data from the cache directly. It's quite nice to have such policy because your client will have response much faster. Your application will consume less memory in terms of like CPU, computing time. And at the same time, you will totally not hit downstream components if there is a cache value already exists. How it works? The poly does not provide some cache providers by default. You need to create some cache provider to use it in policy. For example, here I'm using in-memory cache. Then I'm wrapping this in-memory cache instance within memory cache provider for poly, and just configure my policy instance to use it. Also, you need to provide time to live value. It could be relative time to live, it could be absolute time to live, and it could be sliding time to live. So with a sliding time to live, you have like additional features. So the most used cache will survive longer, so will be not invalidated oftenly. Also, you can use other cache providers. There are plenty of them, and they are compatible with poly cache policies. For example, Redis cache provider, it's distribute cache provider. And also, Poly will let you to specify serializer if your cache provider, for example, stores its cache as a strings. In this case, Poly will automatically serialize and deserialize these strings to classes and from classes on the fly. So kind of nice to have out of the box. Policy wrap. It's another type of policy, but it does not provide any resilient strategy.
When we ask questions, like for the cache, how do you differentiate whether the poly should cache something or not? So if I have the...
Yeah, I got it. And it's kind of a complicated topic, and I would be really happy to show you after. Okay. Yeah, okay. Because I have slides. Basically, I have tons of additional slides.
Okay,
but if I will, but just in 2 words, you need to provide ID.
Okay, good.
I also have this one question about cache. Does that mean that you could basically inject poly into your application just for the sole purpose of, you know, it working as a cache? Like, because you said it's for handling transient errors, but this is like you're actually implementing cache with the use of poly. That's what it looks to me. Can I use it like that?
Okay, quick answer. Basically, you can combine policies, and it's exactly about this one. You can combine policies. So, for example, if you use, for example, retry, yeah, and retry fails, and in the end you have no response, yeah, no, this way it will not work. Sorry. Well, in fact, you can use cache on your own. It's not a problem, like to not use even cache policy at all and use, for example, cache and just add by ID. The policy as a cache is just additional feature, and it's not about handling resilient errors in this case, because it's a proactive policy. Proactive policy even doesn't know about transient errors. As you can see, in the way that how you configure, you do not specify the transient error markers at all. So it's totally agnostic to transient errors. It's more like additional features that you can combine with other policies, because you can mix few policies together. Yeah, but at the same time, yeah, you just use under the hood the cache that you will provide, the cache provider, and it will automatically source and read on the fly of execution. So again, we probably could implement everything on our own. For example, semaphore slim, it's totally fine to use it on your own. But again, do you want to do it? It's up to you. I really like how I can combine policies together easily without my implementation of semaphore slim adapter or something like wrapper. For example, yeah, and policy wrap policy is a policy that will not bring any resilient functionality. It's just our way how we can combine different policies. And because it's fluent syntax that you have seen already many times, it does not let you to specify many policies in one shot. You need to create policy one by one, because of a lot of reasons. And then you can basically wrap them. What is important here to understand, they work, if you are familiar, for example, with ASP.NET Core, they work like a middleware. So there is 2 phases, one of execution to the delegate, and one of handling the result back. So the sequence and the order really is important, yeah? Like with ASP.NET Core middlewares, because they will execute underneath middlewares one by one and will process the result one by one. So it's important not to make like really strange chain of execution. Okay. How much time we have? Okay, we have time. Thread safety of policies. Well, to say like it quickly, all instances of all policies are thread safe and can be used in multi-threaded environment. So, in case if you will create a retry policy and will execute concurrently many delegates, execution of one will not affect on another in terms of if one should be retried 3 times, it will be retried 3 times with another that will be retried still 3 times if it's required. The same as the timeout policy. The timeout of one delegate will not affect on timeout of another. Sure, your delegates should be thread safe by default because Poly will not be able to magically make them thread safe. For example, if they are working with some collection in concurrent way and this collection is not a concurrent collection, you will have problems probably, because your code will be not thread safe. Statefulness of policies. Almost all policies in Poly library are stateless. So from one execution to another execution of another delegate, they will not maintain any state. They just maybe, for sure, for example, a retry should have some internal counter of retries, but it will not maintain it as a state. But 3 policies in Poly, they will maintain state. So it's a circuit breaker, bulkhead, and cache. Circuit breaker should be able to maintain its state in the way to remember its current state, is it open or closed, and how much exceptions were thrown to that moment. The bulkhead should remember and know how much delegates it has on the main queue and how much delegates await for execution in additional queue. And the cache basically need to know basically about its cache provider state and to be able to write and to read from it. What it means for us? That technically it's totally fine even to create all instances of all policies as singletons and reuse them concurrently, and it's fine. But it's not totally fine to create circuit breaker, bulkhead, or cache policy on every time for every request, because they should maintain the state. They should be able to understand where they are, what they are, and how they should react on their state. If you will create a new instance, for example, of cache with new instance of cache provider every time, it will not work. If you will create a bulkhead, so even not a cache, and you will create new instance per request, the bulkhead will be totally useless because it will execute everything without any limitations. Okay, so for example, but you still are able to decide in which scale of reusability you will use these policies instances. For example, you can create one cache policy instance for whole application, probably it will work, or you can create 3 instances of cache policies for different, like 3 services, for example. It's up to you, and you should be pragmatic in this way. What if you want to create 3 instances of cache policy? And, for example, you want to deliver them to your services. So probably you will use some dependency injection, some version of control container, but unfortunately all of them have the same interface. You can use some like named bindings or keyed bindings, but I really don't like such approach. You can create your own class that will basically maybe return instances, depends on some method that you will use or some properties that you will use with some descriptive name. It's fine, but again, there is already some solution in Poly, and it's very easy to use. You just need to create a policy registry instance, and this registry is not in reality something more than just a dictionary with nice API to basically register or to add instances of your policies with descriptive key to take them back after injection of this instance of registry to your services. And when you will get the instances of policies back, you will have already like casted to the interface, to proper interface, this instances. Again, it's totally optional to use, but kind of nice to have and
So
very
wait,
easy.
does that solve the issue that you just said about? Like the free caches, you want to have free caches? That would solve the issue?
Yeah, you can create 3 caches with 3 different names.
Okay.
It will be just registered in the policy registry with different names. You can probably make some workaround to not have magic strings at all, some like name of operator or some constants. Really depends how you want to use it. Poly just gives it and you are able and free to consume this functionality or not. Integration with the .NET Core. Okay, this is the last topic. Probably Microsoft specialized understood how often we are using Poly, especially with HTTP clients, and now you can basically use it very easily with HTTP client factory. That should be probably the default approach for modern .NET Core applications. Instead of using constructions and manual creating of HTTP clients and disposing, to basically have in the end some problems with DNS updates and port exhausting situations. Okay, but it's really easy to use. You just, in the place where you register HTTP client in iService collection, you just need to chain it with additional method, add transient HTTP error policy, and then you can configure which policy you want to apply on all methods of HTTP client. And you can basically choose like wait and retry, retry, retry forever with some additional functionality. For example, like here, amount of retries. What is kind of like not so obvious to understand that you cannot specify markers of your transient errors. So by default, Microsoft implemented it in this way that it's pre-configured. So there are some types of exceptions and types of HTTP result status that will be handled automatically. But if you want to make it really manually, you can create an instance of a policy. It could be even wrap policy, so a combination of different policies. And then via method add policy handler, you can basically attach this policy to the HTTP client that you will register in iServices collection. Yeah. Okay. Summary. So what I really want to tell you is it's very hard to avoid transient errors in modern applications, especially if you are using modern approach. And if you will handle such errors, your clients will be much more happier because they will have faster and more often proper responses. Your application will work faster and maybe consume less resources. Your invoices will be smaller. And what is still important, the downstream components, maybe yours components or third-party components, will be happy to work with you because you will not spam them, you will not overuse them, sometimes when you should not use them or could not use them. The Poly library is very easy to use and very hard to make real mistakes. So I really wish you good luck if you will decide to use it, and thanks for coming. See ya. Oh yeah, and about the cache. Just to immediately answer. So, how we are using it. And cache is here. Not this presentation. It's already refined and a lot of no, not this one, this history, no. Presentation. Sorry, I will try to find. Okay. Where it was? No, it will be not so easy as I thought.
Sure. I have another question.
Okay, I'm hearing.
Can you save the state of the running requests? I mean, you know that you retry for the second time and you, for instance, want to restore the app, and I would like to restore the state, if you know what I mean? Like I have
well, basically, it depends what your delegate will do.
let's say it can be serialized. I mean, does Poly has such kind of mechanism that you can, you know, dump the state of Poly?
Probably not out of the box. So, I mean, if you want to just revert some changes, you will have to do it manually, because no, probably there is no possibility to do something like this. Still, if you want just to revert the state and continue the execution,
Restore.
If you want just to restore the state and continue the execution, or you want just to restore the state and abort the execution.
Like, let's say I have a long-running application, right? And so
Yes.
it retries for the fifth time, and there is a time span of, let's say, 1 hour. And
Yeah.
so it should be retried for 3 hours.
Yes.
And then after 1 hour, I update the application. So I turn down the application and I turn it on again. I
Okay.
would like the same flow to be, you know, continued.
No, if you will shut down the process,
Exactly.
Probably
That
not.
time I would like to save the state somewhere in the file or something. Or you? I know it's complicated. I know.
I mean, it's kind of probably not responsibility of Poly to like perceive the state in this way. So not out of the box, Poly will not do such complicated stuff for you. You will have to handle this consistency on your own, or reverting of state. Poly can provide something in terms of if this process will still survive on the moment of when you want to return. You can use fallback policy, for example, to return something in the moment when you detect the transient error. But like to shut down application, no, there should be at least something where you will read information to what you want to return, and it's totally not the responsibility of Poly, unfortunately. Okay, so about the cache. I hope in this version I have everything. Yeah, 56 slides. It's at least not so refined. Let's make it just really fast. So, the timeout, calculation, trade safety, cache. So, when you want to use cache, there is such thing like a cache key strategy. So, how you will create keys for your cache. And by default, when you execute some delegate, through the cache policy, you can provide the key, like here, via the context. Context is kind of additional thing to speak about, like 10 minutes at least, and you can provide this key. This key will be the operation key, so exactly the key that will represent the execution of the delegate. At the same time, when you create a policy itself...
Can you please make it bigger? Like
Oh, sorry. I will try. I need to find. Okay. So on the moment of execution of your delegate through the cache policy, you can configure the this operation key. This get full op, for example, it's an operation key that will represent basically the exact execution of delegate, of specific delegate. And when you create a policy cache before it, you can provide basically cache key strategy, so how it will create a unique, what to execute, basically determine the key of operation. So it's configurable as well. You can basically here even just add additional value, like here with some width, I don't know, up to you. There was yeah, and this is a custom cache key strategy. So by default, it's operation key with policy key that is not here, unfortunately. And here is a custom key strategy where you can determine, like, really on your own how key will be generated on the moment when you will want to read this cache.
Do we have time for one more question?
Right.
Can you change the parameters on the next execution? Assume that you are calling API, you want to get 100 items, you got timeout. You want to decrease this to less items, like a half, to avoid timeout.
It's in reality. Wait a second. I will try to find this slide. But it will be hard. Policy switch. Okay, the quick answer. There is such thing as a context that you can use as dictionary of objects that you can use to provide anything to your policy, and some callbacks, some things like callbacks. But also, when you provide a delegate itself, this delegate could be really complicated stuff. And if you want to have some dynamic parameter inside this delegate, it could be as a part of your business logic inside this delegate itself. And probably it will be easier because you will be able to unit test it easily. It will be a part of your business logic. I would make it in this way. But also you can somehow to provide it through the policy. But again, when we, for example, unit test something, we don't want to test poly. There are very nice ways how you can test your business logic, even if it uses poly, without basically involving policy like real behavior. You can mock them easily. Poly provides specific type of policy. It calls no policy. You just use it in unit test, and it do nothing at all, like additionally. Yeah, and probably you don't want to add this behavior to policy itself. You want to still keep it as a part of business logic. At least I would make it like this. Depends for sure, like what exactly you mean, like how should behave this parameter.
Okay, so follow-up question to that. So if I want, for instance, to pass to my business logic that I'm retrying or whatever, like the state of the actual retries, do I have to do it all customly via context, or would the context expose something by default? So I would like to know if this call is for the first time, or am I retrying as a parameter to the delegate? Is this possible, or I should not do that?
Okay, I will still try to find this slide in this case. It should be somewhere here. See. Okay, so policy keys and context data. To say the truth, I never tried to do something like this, but as you can see,
okay, this is precisely what I wanted.
When you execute some delegate on the policy, you can provide a context. So this context is a dictionary of basically key of string and value of object, and you can basically bypass anything that you want. Still, I'm not sure is it possible to pass context itself to a delegate, because I'm totally sure that it's possible to pass this instance to your callbacks. That basically it's another topic, but in reality, I never tried.
Okay, so basically you have this retry count, you could add it to the context and access the okay, yeah, makes sense.
From my perspective, still, my business logic should not depend on poly and amounts of retries. Yeah, it should be agnostic to this.
Okay, but that might not be the business logic, but actual plumbing infrastructure that may benefit from knowing if it's failing and maybe adjust something.
Okay. Well, in this way, you will have to figure it out on your own. Again, what I would suggest is to check this context, because it's totally fine to have this context here in the callbacks. maybe somehow it's possible to get it in the handlers itself, I mean in the delegates.
Okay.
But I think even in the circuit breaker you had the counter, right?
Yeah.
So that counter should be available within each consecutive request, because that he was doing that math power to the number of...
Yeah, but it's not a delegate. When I have this math power, I give it to basically this additional function.
Okay.
It's not my delegate,
Okay.
because as you can see, in all these examples, my delegate, it's totally like basically agnostic what it has as parameters even. Yeah. So, yeah. Well, any questions?
Już powoli się czas kończy. Ty mówisz po polsku i zacząłeś mówić po angielsku i się bardzo zdziwiłem.
Słabo.
Całkiem było nie rozumiałem. Musimy chyba zastosować circuit breaker już dzisiaj.
Gratulacje.